the vast darkness of space, where the light of our sun fades into a distant glow, two tiny messengers from Earth continue their eternal voyage. They are old, scarred by radiation and powered by the dying warmth of radioactive decay, yet still they whisper across the void. Their names are Voyager 1 and Voyager 2. Launched in 1977, these twin spacecraft began their lives as humble explorers designed to study the giant planets of our solar system. But what they became is something far greater: the first human-made objects ever to leave the protective bubble of our sun and enter the realm of the stars. It's almost poetic to think about two machines, no larger than a small car, built in the age of analog computers and cassette tapes, now drifting beyond everything we've ever known. They've outlived their creators, their engineers, and even the very technology that built them. Yet, more than 4 decades later, they continue to send data back home, faint radio signals that take more than 22 hours just to reach us. And what those signals reveal is nothing short of astonishing. Because Voyager has now crossed a boundary so mysterious that for years, no one knew exactly where it was or what it would look like when we got there. It's called the edge of the solar system, or more precisely, the Heliopause, the invisible frontier where the sun's influence ends and the galaxy begins. Imagine a place where the solar wind, that constant stream of charged particles blowing outward from our sun, slows, compresses, and finally gives way to the interstellar medium, a place where space itself grows thicker, where cosmic rays from the rest of the galaxy seep in unfiltered, and where silence reigns except for a faint hum, a cosmic vibration that Voyager alone could hear. For nearly half a century, humanity has waited to know: what happens when you finally leave the solar system? What lies beyond the sun's protective shield? And what did Voyager, our lonely traveler, detect as it crossed into that dark and ancient sea? Today, we'll find out. This is the story of how two probes, built with 1,970 seconds technology, ventured further than any machine before them and uncovered the strange, breathtaking secrets at the edge of our solar system. In the early 1,970 seconds, NASA's Jet Propulsion Laboratory was alive with ambition. Engineers, scientists, and dreamers crowded around blueprints and glowing monitors, driven by a single audacious idea to send a pair of robotic emissaries on a grand tour of the outer solar system. It was a mission that seemed almost impossible. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are spread across billions of kilometers. To visit them all in one journey would require perfect timing, unmatched precision, and a little help from the universe itself. And as fate would have it, the universe did offer a rare opportunity. Once every 176 years, the outer planets align in such a way that a single spacecraft could use their gravity like stepping stones, swinging from one planet to the next in a carefully choreographed cosmic dance. This wasn't just clever, it was revolutionary. Each planet's gravity would pull the spacecraft in and then fling it outward with extra speed, saving fuel and allowing it to continue farther than any probe had ever gone before. That's when the Voyager program was born. Two identical spacecraft, Voyager 1 and Voyager 2, were built side by side in a clean room in Pasadena, California. Their design was a masterpiece of engineering elegance: a 3.7-meter gold-plated antenna for communication, 11 scientific instruments, and 3 small computers that had less memory than a modern car key fob. Yet, inside that fragile frame was the power to rewrite our understanding of the solar system. Each Voyager was powered not by sunlight, which fades too quickly in the outer system, but by the slow, steady heat of plutonium-238. This isotope was housed inside radioisotope thermoelectric generators, essentially small nuclear batteries that would keep the spacecraft alive for decades. On August 20th, 1977, Voyager 2 was the first to launch from Cape Canaveral, Florida, a gleaming needle of human hope piercing the sky. Just 16 days later, Voyager 1 followed. Despite launching second, Voyager 1 was placed on a faster trajectory, and it would soon overtake its twin. The Voyagers were not just spacecraft. They were messengers carrying the voice of our species into the cosmos. Each carried a golden record, a 12-inch gold-plated copper disc containing the sounds and images of Earth greetings in 55 languages, songs, the laughter of children, and even the heartbeat of a human being. It was our way of saying, we were here, we existed. As the Voyagers sped away from Earth, they first passed through the asteroid belt, a region many scientists once feared would shred any spacecraft that dared enter it. But both probes slipped through untouched, proving the belt was mostly vast emptiness. And then, they reached their first giant, Jupiter. When Voyager 1 approached in early 1979, the world watched in awe. Jupiter, once just a swirling blur through telescopes, was suddenly alive, massive, colorful, and violent. The spacecraft revealed enormous storms, swirling ammonia clouds, and lightning strikes larger than Earth itself. And there, hovering beside it, were its moons, each one a world of its own. The discoveries were staggering. Voyager found that Io, one of Jupiter's moons, wasn't a dead cratered rock as scientists had assumed it was alive, with volcanoes spewing lava hundreds of kilometers into space. It was the most volcanically active body in the solar system, and Europa, another of Jupiter's moons, showed an icy shell scarred by cracks of evidence that beneath it there might be a vast ocean of liquid water. The Voyagers also discovered that Jupiter had faint, dusty rings previously unknown, and they mapped the planet's immense magnetic field in exquisite detail. For the first time, humanity saw the gas giant not as a distant mystery, but as a dynamic, living world. From there, gravity slingshot them onward towards Saturn, the Lord of the Rings. When Voyager 1 reached Saturn in 1980, the images it sent home were breathtaking. The planet's rings, once thought to be a few simple bands, turned out to be hundreds of razor-thin ringlets intricately braided and sculpted by tiny moons. The probe also discovered Spoke's strange, dark shadows drifting across the rings, caused by charged dust particles interacting with Saturn's magnetic field. And then came Titan, Saturn's largest moon. Wrapped in a thick orange haze, Titan became the most tantalizing discovery of all. Voyager revealed that it had a dense, nitrogen-rich atmosphere, the only moon in the solar system with one. Beneath those clouds, scientists suspected could lie rivers and lakes of liquid hydrocarbons, prebiotic chemistry echoing early Earth. After Saturn, the two spacecraft parted ways forever. Voyager 1's trajectory took it upward, out of the plane of the planets and onward toward the edge of the solar system. Voyager 2, meanwhile, continued on to make humanity's first and only encounters with Uranus in 1986 and Neptune in 1989. It discovered ice giants veiled in blue methane clouds, bizarre magnetic fields, and moons that defied every expectation. By the time both Voyagers had completed their grand tour, they had transformed our understanding of the solar system forever. And yet, their greatest journey, the one no one had dared dream possible, was still to come. Beyond Neptune lies a place where the sun's light dims to twilight, where the solar wind slows to a whisper, and where the faint boundary of our solar system, the heliosphere, begins to fade. This is where Voyager was headed next, into the unknown, into the deep interstellar dark. As Voyager 1 left Neptune far behind, it entered a region no human machine had ever reached before, a place where sunlight fades to a dim glow, and the gravitational pull of the sun begins to lose its grip. This is the frontier of our solar system, a realm so vast and empty that the concept of distance starts to lose meaning. Out here, 1 billion kilometers feels like a step. The spacecraft continued outward, powered by the fading warmth of its plutonium heart. Its radio antenna, only the power of a refrigerator light bulb, kept whispering faint signals across the void, a 2 one-hour-long journey each way between the probe and Earth. For the scientists at NASA's Jet Propulsion Laboratory, every ping from Voyager felt like a heartbeat proof that this little metal traveler was still alive, still pushing forward into the dark. But no one knew exactly what lay ahead. You see, our solar system isn't just planets and moons, it's wrapped in a vast, invisible bubble called the heliosphere. This bubble is formed by the solar wind, a constant stream of charged particles flowing outward from the sunday. For billions of kilometers, this wind fills space, pushing back against the thin, cold gas that drifts between the stars. Eventually, that solar wind slows down, collides with interstellar particles, and forms a kind of boundary, the edge of the sun's influence. But where exactly was this boundary? No one knew. No probe had ever gone far enough to find it. As Voyager 1 and 2 sailed onward through this vast ocean of plasma and dust, their instruments began to detect changes subtle at first, but unmistakable. The first sign came in 2004, when Voyager 1's sensors recorded a sudden drop in solar wind speed. The constant outflow from the sun, which had been racing past the probe for decades, suddenly began to slow, then fluctuate, then grow turbulent. NASA scientists realized Voyager had crossed a mysterious region called the termination shock, the place where the solar wind first crashes into the interstellar medium and slows to subsonic speed. It was like hitting the edge of an invisible wall. Beyond this point lay the heliosheath, a turbulent zone where solar and interstellar particles mix like waves colliding in a stormy sea. Voyager's instruments detected swirling magnetic fields, higher radiation levels, and strange bursts of energy, all signs that the probe was nearing something extraordinary. Meanwhile, Voyager 2, on a slightly different path, confirmed these findings years later. Both spacecraft were now in uncharted territory beyond the planets, beyond the comets, beyond everything we had ever explored. For years, scientists debated, when will Voyager cross the final boundary? That final frontier is called the Heliopause, the true edge of the sun's influence. On one side, solar particles dominate. On the other, the material between the stars reigns supreme. Crossing the Heliopause would mean that Voyager had officially left the solar system and entered interstellar space. Then, in August 2012, something remarkable happened. Voyager 1's plasma detector, which had been damaged decades earlier, couldn't measure the density of particles anymore. But its backup instruments could still listen to the vibrations of charged particles as radio waves. And suddenly it detected a strange, sharp tone, a rising pitch caused by dense plasma oscillations. The readings were unmistakable. Voyager had entered a region where the particle density was 40 times higher than inside the heliosphere. It was no longer surrounded by the sun's wind. It was drifting through the interstellar medium itself. After 35 years of travel, Voyager 1 had become the first human-made object to leave the solar system. Imagine that for a moment, a tiny aging spacecraft built in the 1970 seconds, now sailing among the stars. For the scientists watching back on Earth, the data was breathtaking. The probe confirmed that interstellar space wasn't empty at all. It was filled with a thin mist of ionized gas, magnetic fields, and cosmic rays, the remnants of ancient supernova explosions and the raw material from which new stars are born. Voyager's instruments began to measure strange patterns, bursts of high-energy particles, shifts in magnetic field direction, even faint hums from plasma waves rippling through space. These were the first direct measurements of the space between stars, and the results were haunting. The hum detected by Voyager 1 was a constant, low-frequency vibration, a background tone that seemed to permeate all of space. It wasn't noise, but a steady resonance, as if the galaxy itself were alive, breathing softly in the dark. Some scientists called it the interstellar song. Others simply called it the sound of eternity. Voyager 1 had done it. It had reached the edge and crossed over, But the story didn't end there. Voyager 2, still trailing behind, followed a similar path. In November 2018, it too crossed the Heliopause, confirming everything Voyager 1 had found, but with even better instruments still online. It detected that the boundary wasn't smooth or fixed, it pulsed. It wavered, it breathed with the rhythms of the sun's 11-year cycle. It was alive in its own way, shifting and shimmering like the surface of a vast cosmic sea. For the first time, humanity had touched interstellar space not through imagination or radio telescopes, but with a physical messenger built by human hands. And out there, in the infinite dark, both Voyagers continue to drift. Their cameras are turned off now, their instruments slowly shutting down one by one to conserve power. But still, they whisper to us faint, fragile signals crossing billions of kilometers. Each transmission takes over 22 hours to reach Earth. By the time engineers hear it, the data is almost a day old. Yet, even after nearly 5 decades, they are still speaking, still exploring, still carrying our story into the stars. Beyond the Heliopause lies a realm no human instrument had ever entered: the interstellar medium, the space between stars. To most, it might sound like emptiness, but Voyager revealed that it's far from empty. When Voyager 1 crossed into interstellar space in August 2012, the world expected silence. After all, beyond the reach of the sun's magnetic field, what could possibly be out there to detect? But instead of silence, Voyager heard something extraordinary. A faint vibration, a low, ghostly hum. It wasn't radio interference, and it wasn't noise from its instruments. This was real, a natural tone resonating through the plasma between stars. Scientists called it plasma wave oscillation. You can think of it as the sound of space itself, the gentle ringing of charged particles vibrating in the cold, dark sea beyond the solar system. To the human ear, it would sound like a haunting whistle, slow, rising, falling, almost like the sound of wind through a canyon. Voyager had tuned into the voice of the galaxy. For years, the probe recorded subtle variations in this cosmic hum. Sometimes it would grow louder, sometimes fainter, sometimes higher in pitch. Each fluctuation told a story: a solar storm reaching across the void, a wave of energy from distant stars, or the shock of particles colliding in interstellar space. Through these delicate vibrations, Voyager's instruments painted a picture of what the space between stars is truly like. And what it found was stunning. Interstellar space is filled with a thin mist of plasma particles so diffuse that a single cubic meter might contain only a few atoms. Yet, this sparse matter holds immense power. It's charged, magnetic, and constantly in motion. Voyager detected that this plasma was denser and hotter than expected, about 40 times denser than the material inside the heliosphere. That was the first clear proof that the probe had indeed left the sun's domain. It also measured something else: cosmic rays, high-energy particles that travel across the galaxy at nearly the speed of light. Inside the heliosphere, these rays are mostly deflected by the sun's magnetic shield. But once outside, Voyager was exposed to their full force. The instruments showed a sharp rise in cosmic ray intensity, a cosmic rainstorm of charged particles, remnants of ancient supernova explosions that had happened millions of years ago. Each one was a messenger from a different part of the galaxy, carrying stories of stars long dead. But even as the data poured in, something strange began to appear. Voyager's magnetometer, which measures magnetic fields, showed that even beyond the Heliopause, the magnetic field lines weren't completely alien. They were still aligned closely with the direction of the sun's field. This puzzled scientists. It was as if the interstellar medium wasn't fully separate, but somehow still connected to the heliosphere, a kind of invisible magnetic bridge linking us to the stars. Then came the most eerie discovery of all, something Voyager scientists called the interstellar hum. For years, Voyager 1's plasma wave instrument continued to detect this faint, constant tone, not bursts, not flares, but a steady background vibration. It was as if the galaxy itself were singing a single endless note. In 2021, researchers finally revealed what it was: a continuous plasma signal, the ever-present resonance of interstellar gas vibrating between stars. It's been there all along, we just never had an ear to hear it. Voyager gave us that ear. To some scientists, this was more than a discovery, it was a revelation. Because that steady hum told us that space is never truly silent. Even in the deep, cold void, there is motion, energy, and life of a different kind, the living heartbeat of the cosmos itself. But Voyager wasn't just listening, it was also watching. Even though its cameras had long been turned off to save power, its detectors kept sensing strange particle patterns, ripples in the plasma, bursts of radiation, sudden shifts in magnetic strength. These could be the fingerprints of interstellar shocks, powerful waves generated by distant supernovae or massive stellar winds colliding across light years of emptiness. At one point, scientists recorded a massive burst, a cosmic shockwave from our own sun that had traveled billions of kilometers outward, taking over a year to reach Voyager's position. When it finally arrived, the probe's instruments registered the hit, a sharp rise in plasma density followed by a slow fade, like a distant echo of the sun's heartbeat reaching across eternity. That moment confirmed something profound. Even out there, beyond the solar system, the sun still makes its presence known. Its influence doesn't vanish abruptly. It fades slowly, gracefully, like the last notes of a symphony. And Voyager is still listening to those notes. Every bit of data it sends home, every whisper from beyond helps scientists map the structure of our galactic neighborhood. We now know that the Heliopause isn't smooth or static. It bends, it ripples, it breathes with solar activity. It's a living boundary between our world and the interstellar sea. Voyager 2, following 6 years later, confirmed it all, but with more detail. Its plasma detector was still fully functional, allowing direct measurements of temperature, pressure, and density. What it found matched Voyager 1's readings almost perfectly, but with slight variations, proof that the Heliopause itself changes shape over time. Together, the two probes painted the first picture of humanity's true cosmic shoreline. We now know that the solar system doesn't end where Neptune or Pluto lies. It extends far beyond, encased in a protective bubble carved by our sun's magnetic breath, a bubble drifting through a galaxy of stars. And at that boundary, Voyager waits, recording every sigh, every vibration, every ripple that passes through the cosmic tide. For nearly half a century, it has been our silent ambassador, a tiny spark of human curiosity floating in the vast dark, listening to the song of the stars. Each day, its power grows weaker, its instruments colder, but it keeps going. Even now, billions of kilometers away, Voyager is still working, still reaching, still teaching us about the edge of the sun's domain. And one day soon, its voice will finally fade. The last signal will reach Earth, a faint, final whisper, before it drifts into silence forever. But even then, Voyager will continue its endless journey, gliding among the stars, carrying with it a golden record, our story, our music, our voice, a message to the cosmos that says, "We were here, we dared to explore." In the cold silence beyond the sun, two machines still drift, Voyager 1 and Voyager 2. Their instruments are weakening, their batteries fading. The last of their power will run out sometime in the 2030 seconds. One by one, their sensors will go dark, their antennae will fall silent, and then, after nearly 60 years of travel, they will become what they were always destined to be: eternal wanderers. Yet even when their voices fade, their story will not end. Each Voyager carries a golden record, a time capsule etched in copper and gold, designed to last for 1 billion years. On that record is the story of Earth. Greetings in 55 languages, the sound of rain and ocean waves, the laughter of children, and the music of Bach, Beethoven, and Chuck Berry. It's a message to any civilization that might one day find it an introduction to who we were when we first looked up and dared to cross the stars. Imagine it. Billions of years from now, long after our sun has swollen and died, the Voyagers will still be out there, gliding silently through interstellar space. They will outlast our planet, our species, perhaps even our memory. Long after Earth is gone, they will still carry our heartbeat. The data they've sent back, those faint radio pulses from the edge of forever, have already reshaped everything we know about the solar system. They revealed the true boundary of the sun's reach, mapped the heliosphere, uncovered the strange hum of interstellar space, and showed us that the galaxy is alive with motion and sound. They proved something far deeper than science alone. They proved that curiosity, that relentless human need to ask what's beyond, is our greatest strength. From the launch pads of Cape Canaveral to the farthest reaches of the Milky Way, Voyager stands as a monument to what humanity can achieve when it looks outward instead of inward. Every kilometer it travels is a reminder that we were never meant to stay confined to one world. As we speak, new missions are already being imagined, spacecraft that may one day follow Voyager's path, equipped with far more advanced instruments, capable of exploring deeper into the interstellar medium, maybe even reaching the nearest stars. But no matter how far they go, Voyager will always be the first, the pioneer, the scout, the whisperer of the cosmic sea. Someday, perhaps millions of years from now, a distant civilization might detect a strange object drifting between the stars. They might intercept its golden record and listen to its sounds, the wind, the ocean, the heartbeat of a blue world that once was. And in that moment, they will know that they are not alone. Someone came before them, someone who looked up at the night sky and dreamed. That is the true legacy of Voyager. It's not just about where it's been, but what it represents: the unbreakable spirit of exploration, the quiet defiance of time, and the message that even in the vast silence of space we dared to speak. And so, as the faint signal from Voyager continues its slow journey home, taking almost an entire day to reach us, it carries more than data. It carries hope. Hope that our curiosity will never fade. Hope that we will continue to explore. Hope that somewhere out there among the stars, our voice will be heard. Voyager is still traveling beyond the sun, beyond the planets, beyond everything we've ever known. And as it drifts through the stars, it carries our story. For more journeys into the unknown and more mysteries of our cosmic home, make sure to like, share, and subscribe. Because out there, the universe is still calling.